Alright, this is practice problem 9.3, which says predict whether these molecules are polar or non-polar. Alright, so if we first just start out with bromium chloride, okay, the first thing you should know is that this is a Br bond to Cl, right? It's a diatomic molecule, which means that it's going to always be polar, okay? And the chlorine is more electronegative than bromine, and so the electron's being pulled from the bromine to the chlorine. And so the first one is polar. B is SO2, okay, you notice there is no charge, okay, and if we draw the Lewis structure for this, you should have sulfur bound to an oxygen, okay, and when you work through this Lewis structure, you should get a double bond on one of the oxygens. So we have 1, 2, 3, 4, and then we have 1, 2, 3, 4, 5, 6, okay, and then the sulfur in the middle is going to take the last two electrons. Okay, so that is our structure for SO2. Now, what you'll realize is that this would be in resonance then with oxygen double bond to sulfur. Bonded to oxygen, 2 on the sulfur, 1, 2, 3, 4, 5, 6 on that oxygen, or I'm sorry, 4 on that oxygen, okay, and 6 over here. Okay, so we have these. And so at that point, since this is in resonance, we can kind of think of this as basically we have sulfur bound to an oxygen, okay? The sulfur has one lone pair above it, okay? And both of these are kind of pulling the electron to the more electronegative atom, okay? And this is a bent molecular geometry. And therefore, this is going to be polar as well. C, we have S, which has 3 fluorines attached, okay? And I'm going to go ahead and show you exactly what this structure looks like. Each of the fluorines is going to have 6 electrons around it, okay? So it takes a minute to draw those out. Oh, bear with me, we're getting there. Now it probably looks even more confusing, but we have 6 electrons on each. Okay, so this would be our overall structure. Now each of these fluorines, since it's the most electronegative atom, is pulling that electron towards the fluorine from the sulfur. Okay, but what you'll notice is that the molecular geometry is octahedral, and because of that, each of these are pulling equally, okay, since we have all fluorines attached. And so since the bond dipoles are going to cancel, we have a non-polar.